We're going over the Chapter 7 review. We'll have a couple of videos here. First of all, we want to write an equation that fits the table or the graph. And we have a table on number 1, and we learned way back starting on page 95 and then later on through 97, page 194. And then even before that, in the beginning of the book, in the preliminary pages, we learned about regression rules. But we will learn that the first thing we're going to do with the table is do some investigation by looking at the change in y, change in x, and hunting for patterns. And so the first change in y is a gain of 2. Its change in x is a gain of 3, and we get a 2/3. The next change in y is a gain of 4. Its change in x is a gain of 6. We put that change in y over change in x, and it's still a 2/3. And we learned that if the change in y, change in x is constant, then it must be linear. If it's linear, then we also need the y-intercept, recall, because the equation of a line is y equal mx plus b. Now, we've taught you by now to use the graphing calculator to come up with the equations based on the fact that you now know it's a line. And we'll do that in a moment, but we still want to remind you of how to find the y-intercept on paper. Remember that the y-intercept is the value of y when x is 0, but that particular value was not in the table, so we couldn't find our y-intercept that way. So we're going to find our y-intercept by calculating it. And we learned how to do that on page 97A and then later on page 101. And here's what you do. We're going to pick a point from that table. If we choose the first point, then it's the ordered pair 3 for x and 3 for y, 3, 3. And the slope, which we just calculated to be 2/3. And we're going to plug those into the formula y equal mx plus b and solve for b, which is the y-intercept. So we take the y of the point in place of y, the slope 2/3 in place of m slope, the x of 3 in place of x, and the only remaining variable is b, so now we can solve for b. As we multiply those fractions, we see that the 3's cancel. I'm going to move my work over here. So we would have 3 is equal to 2 plus b. We would undo addition by subtraction, and we would get that the y-intercept b is 1. Excuse me. Looking at that 2. And so we see that we have a slope of 2/3 and a y-intercept of 1. Plugging those back into y equal mx plus b, this time replacing m and b only, we would have y equal m for slope, which is 2/3, x plus our b, which was 1, and there's the equation in slope-intercept form. Any questions on number 1? Again, we could have gone to the graphing calculator. We could have gone to Stat, Edit. We could have put our x's in L1, 3, 6, 12, y's in L2, 3, 5, 9, 3, 6, 12, 3, 5, 9. 3, enter, 6, enter, 12, enter, go to the y's. They were 3, 5, and 9. 3, enter, 5, enter, 9, enter. We then would go to Stat, arrow to the right to calculate. Number 4 is a linear regression, so I'm going to hit the number 4. I'm going to hit enter, and it gives me y equal 2/3, that's what 0.6 repeating is, x plus 1. Same thing we got as when you did it on paper, okay? So we can do our work on paper, verify it on the calculator. So we're going to begin number 2 the same way. We're going to begin by investigating the change in y, change in x to help us determine, using the regression rules at the front of the book, whether this is linear, quadratic, or exponential. Those are the only things we know so far. So we're going to look at the first change in y, which is a loss of 27. Its change in x, which is a loss of 3. And so we would get a negative 27 over a negative 3, which is a 9. We take the next change in y, which is a loss of 108. Its change in x, which is a gain of 6. And you probably have seen an error here. I apologize. That should be a plus 3, minus 9. And so on the second one, we have a negative 108 over 6, which reduced is an 18, so we get a negative 18 over 1. And there should have been another data point, right? Because we really don't have enough information. If you look at that to solve, but in your addition, there's some more numbers. It's just not in my transparency model here. There was a 15 and a negative 225. There was also an 18 and a negative 324 that was added to the data table. And so the next change in y would be 56 from 100. 56 and 25 is 81. So it would be a loss of 81 over a gain of 3. And so we would put that negative 81 over 3, which would give us a negative 27 over 1. And what you see is we have some inconsistency here. We do not have the same slope or the same change in y, change in x. Therefore, that is not a constant rate of change or a constant slope. Therefore, we know it's not a line. We would want to investigate the negative 9 over 1, negative 18 over 1, negative 27 over 1, and hunt for a pattern like you might say times 2 here, but it's not a times 2 here, so it's not that. You might say a minus 9 here, minus 9 there. And so we can see a minus pattern. So we get the idea that it's not linear, it's possibly quadratic. And so we're going to do a quadratic regression. Sometimes these tables that were given have problems. Let me show you what's wrong with this one. 3, 6, what would normally come next? 9, 12, 15. There's a 9 missing in the data table if we try to keep our x's in order. And it makes it where it's a little hard to find the patterns to determine what it really is. We have enough to know it's not linear, it's not acting exponential, so we're going to make the assumption it's quadratic and go from there. So we're going to plug these numbers in, 3, 6, 12, 15, 18, to our stat edit L1. Stat, edit. To clear, we're going to go up, clear, down, over, up, clear, down. I'll remember those numbers this time. 3, 6, 12, 15. So 3, enter, 6, enter, 12, enter, 15. Remember the y's right quick. 9, 36, 144, 225. Nine, -9. Enter. Put it in the wrong spot. Apologize for these little errors. -9. Enter. -36. Enter. -144. Enter. -225. Enter. We entered our data in L1, L2. We're going to go to Stat, arrow to the right to calculate. We've determined that it's quadratic. Enter. And so we get -1 for A, 0 for B and C. That means it wipes out the whole end of that equation. And what we're going to have is y equal -1 x squared. Y equal -1, plugged in there, x squared. The 0 here wipes that out. And so our answer for number 2 is going to be y equal -x squared. That's a board full of stuff, isn't it? Y equal -x squared. We could have done that mentally, right? 3 squared is 9, so it's -3 squared. 6 squared is 36, negative. 12 squared is 144, negative. So we can see that it's negative. Whatever x is squared will produce our y value, okay? Any questions on 1 and 2? Okay. Number 3, we're trying to go from a graph to an equation. We can use our eyes to tell that number 3 is linear and that number 4 is quadratic just by the way the graph looks. To find a linear equation, we find slope and y-intercept. The y-intercept, remember, is the point where the line crosses the y-axis. This is the origin. And so we can see that this line crosses the x-axis there. It crosses the y-axis here. We want the y-intercept. And it crosses the y-axis at -1, 2, 3, 4, 5. So my y-intercept is -5. Okay. Slope is change in y over change in x, or rise over run. So we want to think about how to go from one point to another, and we always want to run right. So we're going to say I'm going to go up 1, 2, 3, 4, 5. Up 5 for rise. To the right 1, 2 for run. Up is +5. Right is +2. And so my slope is 5 over 2. So my equation will be y equals slope 5 over 2 times x. And then the y-intercept, minus 15 for negative 15. Any questions on number 3? Page 97B is directions for that. It says, look with your eyes to find the y-intercept, which is the point where the line crosses the y-axis, and the slope, which is the rise over run from one point on the graph to the next. Okay. Number 4, we can tell visually, is a quadratic. What's the only way that we've come up with the equation of a quadratic? Well, you can think a while, and if you spend a little time there, you'll only reach one conclusion, and that is that to come up with an equation of a quadratic, we took a table of xy values, we put x's in L1, the y's in L2, and we hit stat edit, quadratic regression, and we had the calculator do it for us. So we know that the only way we're going to get an equation of a quadratic is to build a table of points. We're going to build those table of points by looking at the points on the quadratic itself. Now, we like for our x's to be in order least to greatest. That means I need to start over here where my x is the smallest and work my way around the parabola this way to write those points. And so the first point, if we can identify our origin correctly, is here for the origin. So the first point would be to the left 1, 2, 3, up 1, 2, 3, 4, 5, 6, 7. Left 3 is negative 3, up 7. The next point, as we go around this one, which would be this point, would be to the left 2, up 2. The next point as we go around is this one, which is left 1, down 1. The next point is this one, which is left or right 0, and down 2, which is our vertex. The next point is this one, which is to the right 2, up 2. The next one is this one, which is to the right 3, up 7. And so we have created a table of points that are on that parabola, with the x's in our table being ordered from least to greatest and the y's to be the things that follow. So we're going to go to our calculator, stat edit, stat calculate. We're going to clear what's in there out, up, clear, down, over, up, clear, down. My x's were negative 3, negative 2, negative 1, 0, 1, 2, 3. I need to remember my y's. I left out the 0.11 in my table, didn't I? I left out the 0.1 negative 1. So there should have been placed a 1 negative 1 right in there. I apologize for that. We'll sneak that little guy in. So that's going to give us a 7, 2, negative 1, negative 2, negative 1, 2, 7. 7, 2, negative 1, negative 2. So for my L2, I have 7, 2, negative 1, negative 2, back to negative 1, back to 2, back to 7. I'm going to go to stat, arrow to the right to calculate. I know it's, whoops, Arrow to the right to calculate. I know it's a quadratic, number 5. Enter. And so my answer is 1x squared. That's gone because of the 0 minus 2. So I have 1 understood x squared. So I have x squared minus 2. X squared minus 2. Any questions on number 4? Okay. Number 5. Number 5, we're multiplying binomials, and the way I taught this is that we would look at the operations and say we have a parenthesis. We have a parenthesis crammed on a parenthesis, which is multiplication, and we have another parenthesis. And we said according to the order of operations, we would do what's in the parentheses first. In this one, we have addition, and this one, we have subtraction. To add or subtract, you have to have like terms, and those are not. Those are not. So you cannot do what's in either parenthesis, which takes us to the operation multiplication. Now we have a multiplication crammed between parentheses. When multiplication is on parenthesis, we check for distributive. And we know that you can distribute onto a one lesser operation, and the thing lesser than multiplication is either addition or subtraction. So we're going to distribute this multiplication onto this subtraction. I'm going to clean that up a little bit. We're going to distribute the multiplication of this binomial onto subtraction. We're taking this binomial and distributing it. So that binomial, 3x plus 5, will be distributed onto this piece, 4x. That same binomial, 3x plus 5, will be distributed onto the second piece. And that second piece, we have to carry the minus as a sign, and we call it a negative 7. And then we're going to distribute again. We multiply the numbers 12 and we multiply the names, and you get a new name. And when you multiply with like bases, you add the exponents, so you get 12x squared. We multiply 4x times 5 and we get 20. And then we go to the next side. We've got negative 7 times 3. When you multiply with different signs, it's a negative 21. To show that the result is negative, we put a minus to separate our terms. And then a negative 7 times 5 is a negative 35. And again, to show a negative, we put a minus to represent our sign. I saw a mistake. We have 4x times 5 is 20x. That's supposed to be an x. I apologize for the delay in getting that there. We now have some like terms in here. We have an addition and a subtraction and a subtraction. And when it's down to addition and subtraction, we search out and combine like terms. And so we're going to get 12x squared, 20 positives and 21 negatives. There's one more negative than positives. We're going to have a negative 1 understood x minus 35. So we simplified by distributing. When you distribute a binomial through another binomial, the result is a quadratic. Okay? Now, the next one, we really want you to be able to focus in on the fact, and I believe that this is on page 204. that's a special case, and that special case is the difference between two squares. Because when you look at the first binomial and the second, they both have that in common. They both have the 5 in common, and therefore the only difference is one has a plus and one has a minus, and those things have fancy names which we call binomial conjugates. The result of multiplying binomial conjugates is the difference between the two items squared. Your items being the x and the 5. And so we don't have to go through all of this fancy distributive. We can just recognize their binomial conjugates, rewrite it as the difference between the two items squared, square the one you can, and we get x squared minus 25 for an answer. That's not saying you couldn't do it the long way. That's fine. It's just not as easy. Any questions on number 6? Okay. The second half of this lesson uh, will begin with number 8. So I'm just going to go ahead and do one more problem here as it relates to what we're doing here. So number 7 will be the last one on this part of the chapter 7 review recording. The area of a square, we immediately saw formula words. So we're going to write that down on a word sentence line. We would automatically look up the formula. Area of a square is side square, but that formula is not on a formulas chart that we use. That's something that we've said you have to commit to memory. Now this time it says in terms of x, which means we're not going to write the area in terms of s. So this particular question demands that we replace s with the x stuff. We're going to go ahead and write characters. The characters of the story would be area, which we don't know, so we're going to leave it A. And side, these are the pieces of the formula, which they've asked us to call x plus 7. And so we're going to substitute the x plus 7 in for s. Now, this again goes back to that distributive law. We have a higher operation exponent that's going to be attached to a lower operation addition. Even though it's a 2 lower, you still put it in parentheses, x plus 7 in squared. If a higher operation is attached to a lower, the lower must be put in parentheses. But you're only going to distribute if it's a 2 lower. What am I talking about? Some people may think, well, you can distribute that exponent of 2. But that's an exponent, and that's addition. And remember that our rules for distributive property said that you can only distribute onto a 1 lesser. So an exponent will only distribute onto multiplication and division. It will not distribute onto addition or subtraction. So you cannot distribute. Well, if you cannot distribute, what are you going to do? You're going to do what that exponent says. An exponent of 2 says square it. Multiply it by itself. And so we're going to take that binomial x plus 7 and we're going to multiply it by itself. Now, we can use the long method of squaring that binomial, multiplying it through as fancy distributive, or we can know the rule for squaring a binomial. I'm going to go ahead and use the rule for squaring a binomial. It would be the first item square, x squared, on this end. The second item square, 7 squared, is 49 on the other end. And you're going to have two of those x times 7s. It's like there's two of those going on. So in the middle, you have 2 times the product x and 7, or 2 7x's. And we get those 2 7x's put together, we get a 14x. And so we squared the binomial. Again, we could go back and do that one like we did number 5 as we distributed the first binomial through the second. Any questions on the first 7 problems on the Chapter 7 review?